developer experience stuff, by the way. I think that's really cool, just to say. Yeah, so that's me. If anyone wants to ask questions about the bird, you know, can do that later. It's not really relevant to the talk, so you know. Yeah, so I think the first thing is, why would a car company need such a big cloud presence? You know, why am I even talking about this? And it's really due to the change within the industry. And whenever there's change, especially into new industries, that's where there's fundamental engineering problems to solve. You know, not just another Spring Boot app, etc., but some real things you have to think about and solve. And that's why hopefully I can kind of illustrate some of that stuff for you today and give you an idea about how we work. So there you go there. JLR cars, hopefully, if anyone's got one, knows that they are desirable vehicles. But increasingly, the way the industry is going is that the stuff that's not on the vehicle is as important in some markets, especially key markets to us like China, for example. I won't even go into all the mad features that is just considered par for the course for a car in China, but one example is in-car karaoke. Seriously, it's considered the baseline. Have that or don't bother selling a car. Crazy stuff. So the off-board, probably a Roku box would be quite useful on some of it, for example. You know, huge amount of change in the industry. You know, this is part of what we do in Manchester to try and enable some of this stuff, and it's increasingly important as well. It's important now, and it's increasingly important. And some of the changes, in fact, it's considered as important as the quality of the vehicle in some respects. So you can see there's some allusions to what I've just said. The technology is part of that experience and part of the brand. And when you have a powerful brand that's sold as a luxury product, you know, 75, 100 grand, 150 grand cars, your experience for your customers for all the digital services has to be similarly high quality. And without going into detail on here, the other issue with automotive is that the industry as a whole is a little bit behind the curve in many ways. So until very recently, pretty much every vehicle manufacturer got their off-board software experience from about 3 big vendors around the world. There was no differentiation. They were all pretty terrible, to be honest with you. You know, the experience, for example, our mobile app that was driven by that had a score of about 1.7 on the iOS store. Pretty poor, and that was pretty standard, to be honest with you, across it. It wasn't very good. It wasn't really part of the core product. However, you know, that has changed significantly, and thanks to Elon and Tesla, their cars are actually a bit rubbish if you look at a lot of metrics, but their software, they took control of all that and did that themselves, and a bunch of car companies, including JLR, has took control of that likewise to try and push that stuff forward. So you can just see some of the things the future has there that you really need. You fundamentally could not do this on board. So ML, a lot of these things rely on ML. I can guarantee however many NVIDIA graphics cards you stick on a car, they will be at 100% usage immediately because of all the stuff that's required. You think about autonomous driving and all that kind of stuff, that's basically another massive ML payload. So anything you can do in the cloud, essentially, is cheaper, and you can actually do it rather than never having the capacity to do it. You think about the power management problems you would have on a vehicle as well. It's better with an electric vehicle, but still, every time you use a watt of power, you're reducing the range of your electric vehicle. So a huge trade-off for how you do all this stuff. So the cloud can come into play and really solve some fundamental problems here. Media streaming, we'll catch up later. What scale? So what are we talking about here? One key difference between a lot of companies and what JLR and other car companies do is a lot of the data costs are ours, because there's use cases for the customer, but there's a lot of data we need as well. Without getting into massive detail on some of this stuff, every little device on that car is producing absolute massive data, and you can improve the reliability of your car by getting hold of it and predicting problems. That's just one use case, but to do that you need a vast amount of data off the car. So when I say vast, for example, this kind of thing, a single vehicle generating this volume of data, and imagine paying for this as well as a company. How do you manage that? How do you deal with it? So, you know, the key thing is get it when you need it. And the fundamental thing around our platform is the configurability of all of it. So everything we've written, every bit of data coming off that car, and everything it does really can be dialed up and down like a tap, basically on a per vehicle basis. And that kind of allows us to do things like this where we need it, but not bankrupt the company, because we're basically spending it all on data costs. And that configurability is kind of unique in the industry as well. You know, all the competitor platforms for this do not have that. and the latency that we've achieved is unique as well, and that really opens up some of this stuff I mentioned. Some of these features don't work without low latency and the ability to actually pay for it. So again, you can see this. V2X, this is another massive use case in the future and another real source of change. Increasingly, it depends on where you are in the world. If you're in, Tokyo or San Francisco, for example, some of this stuff's a reality now. In China, some of this stuff's a reality. That your vehicle is going to be talking directly to other vehicles. It's going to be talking to it's going to be talking to traffic light systems, smart city systems, all this kind of stuff. Is you have to get ahead of the game on this stuff. Like when the infrastructure's in place, you need to be ready to use it if you're going to differentiate your product. So imagine all the fundamental problems here, and dealing with all the legislation and all of the problems around the world, different technology infrastructures, an absolutely vast amount of problems to solve there, all adding into technical challenges to solve problems at scale, and that's primarily what I'm going to talk about is scaling. And as you can see, I have read the presentation. I'm not going to read all this out, don't go to sleep, honestly, this is just an intro for some of this stuff. So, dev at scale, and I'm going to talk about two things, because I think there's some technical things that we've done and some technical challenges, but one thing that's often forgotten is the people, which is why I really like the developer experience thing you mentioned. Really, really key to us is scaling teams of people, autonomy, and how you actually physically enable that. So, in JLR, quite an old-fashioned industry in some respects. Us in Manchester, trying to pull it forward into a more tech-first cloud way of dealing with things. We often make quite tiresome analogies about how CI/CD pipelines are like a production line for cars, and we can get like very senior automotive executives like nodding and going, "Oh, I get it, I understand." So that's really the thing behind this. And really, this is how you do it, regardless of the detail. Maximise that autonomy and have governance though, because the other thing about automotive is it's hugely highly regulated. I've worked in aerospace as well, and even though you'd think that might be more regulated, I think it's the other way around. I think the aerospace industry is better at working with the regulators to provide governance that works. And I think automotive is perhaps, again, as an industry, kind of been just taking what's been given. So there's a huge amount of challenges there as well in terms of what you can do. And we've actually been working with the regulators to make them a bit more modern in this space as well. I don't know if anyone's seen a few people nodding. I suspect you've worked for Bosch or some other automotive company, if you are. But yeah, you can't not have that governance, so you need to prove this is tested. You can't just do it because it makes your software better, you have to. You cannot put that, you cannot connect that to the car without it. You'll fail, you will get massive fines, you potentially can't even sell your car. It'll affect your NCAP stats and stuff like that really affects the sales. But how do you do that in a scalable way? It's all about governance. Every time there's a person in the loop that isn't the engineer writing the code, maybe even with AI a little bit less of that perhaps, but everything else, you want to automate that as much as possible. So that's basically what we do. Every single thing around test coverage, quality and security compliance, they're all governed, it's all audited, all ticked off by regulators, but that pathway for a code change is as quick as it can possibly be. All of that's automated, there's no other people in the loop. So you can see there's some stats up there. We achieve with this a very low change failure rate, 40 to 80 production releases today, time to live less than 30 minutes in this regulated environment. Industry-leading latency for a connected car platform, 500 milliseconds. Trust me, without any context, that might not seem like a lot, but the legacy platform we were using was more like about 7 seconds for similar stuff. Tesla's is about 3 times that, for example. So, and you can see there as well, I think this model of pushing autonomy, and I'll go into a few of the details in a sec, proof of the pudding is BMW's equivalents, they're trying to solve similar problems. We have about a seventh the number of people they have, and our platform for our next generation is ahead of theirs. Obviously everyone's a bit cagey about this, but we both use Amazon and they let things slip sometimes about this. So we'll take that as given. So yeah, just some key technical considerations that we always look for. To try and scale this out globally in all those different markets, that includes China, and we don't want to develop 2 platforms, and there are other markets as well where Amazon is not always the same. You will not find the same services in every market that's there. So it creates some real pinch points. If you may want to do things in a certain way, but unless you're going to double the size of your engineering team and build a second version of it to run in a different market, you have to account for all that's in there. That's a key thing. Another key thing we look at is
We don't want to have thousands of people just looking after the day-to-day, so we will always favour a managed service. Always, always, always. We make exceptions where required, but that's a key principle for us as well. And again, building a reusable platform is a key one as well. You want people to work autonomously, but also us in our engineering and architecture community, we think it's really, really important that you make sure you're building as little as you need to get the job done. And it's really key challenge. It's a really difficult challenge to get an autonomous group of teams while still having that coordination across them as well. And that's really what tech leadership's about these days. I think not just weighing in and making decisions, but like gluing all that stuff together. And then behavioural principles. How do you scale that out for teams? We have clear SLAs on things such as the amount of time a decision can take. They get escalated as well, so it's not just code and merge requests. All decisions that get in the way of that pathway to code going live can get escalated, can get dealt with, to try and keep that loop turning. And again, no blame culture either, because otherwise people aren't brave and they're not willing to make changes at pace. Key kind of behaviour that we look for. And yeah, T-shaped engineers. People have roles, they have specialisms, but we think it's really, really important that people can contribute wherever they can. We really encourage that around people, so we don't particularly like people saying, I'm a tester, so I test, or I'm an infrastructure guy, so I do infrastructure. That's what you're going to spend most of your time doing, right? But people are capable of more than that these days. It's usually better for everyone if you let that happen. We try and enable that as much as we can. So I'll move on. Again, too many words, but it's basically the key lines I just went through. Be strict on the basics through guardrails, but otherwise fully empower your teams to make as many decisions as possible. Empower your squads in other ways, so make sure that your teams have freedom to make decisions where they can, or freedom to experiment as well. Carve out time for that. Google's 20% time model, we follow that. That's how we enable that, and we try and produce some good technical improvements through that process. And then constantly review all of that as well. It's easy to say, oh, we've done DevOps. It's easy to say, oh, it's this fast or whatever. Constantly looking for those improvements, both in how you operate and the technical side of things. It's key to us. Improve where you can. And another key one, I think sometimes when people get into doing this, they can often try and compare apples to oranges in a way. So you look at one team and say, that's doing really well, and this team's not. And it becomes like a point of contention. You kind of say, oh, we're going to change it to work that way. I think we're experienced enough, generally speaking, most experienced engineers are, that you can't really compare one team to another necessarily. You can just look for where there's benefits and best practice. And that's a key thing for us as well. We're not interested in putting ankle bracelets on engineers and telling them what good looks like, basically. And then the support side of things, again, once this stuff's into production, how do you even deal with all of this stuff? We template everything. We empower our teams based on those templates. People can diverge as long as they do the basics. But actually a squad can join the team, start on something new, and have a pipeline that deploys everything into production in one of our supported code sets immediately, basically. It's all there. It's really, really quick to onboard new teams. A lot of work went into making that happen. Whether it's being deployed as serverless or in Kubernetes, all that stuff is there, ready to go. All parameterized as well, so reuse is really, really important, and we, it's a standard principle behind it. We'll template and parameterize everything. Then observability. So when you put these things out there, whether you're talking key ML payloads running in the cloud, future kind of use cases like connected cities or just driving a mobile app, you need that ops and monitoring capability. All this stuff is kind of revolutionary for the automotive industry. It's brought in with our kind of tech expertise from other companies. This is some stuff from Datadog there, if anyone's used it. All the kind of infrastructure, all those deployments are managed, automatic rollback, all that kind of stuff, multi-region failover. If you're trying to go for that 4 nines, if you're trying to go for that industry-leading latency and uptime, you need all that stuff. And that, I mentioned that configurability basically lets us afford this, because if we tried to do this with all of the data all the time, we couldn't do that. So that configurability, that dial, and being data-driven about it basically allows us to follow all these best practices. So you can see some stuff there. Incident response as well. It's all really, really standard. Pager duty, all that kind of stuff. So even though it's coming off a car, our ops layer that we built here allows us to respond to incidents properly. You wouldn't even know it's a car basically. This could be supporting a mobile app or anything basically. Scalability testing. So I think that one of the last differences, and again, for me, it always comes down to where you differ is where the engineering problems are. Is the intro alluded to the fact the car is kind of in some ways semantically becoming a bit like a mobile phone. But mobile phones are a standard ecosystem that's been out there for a long time. There's 2 big OSs, right? So anytime you want to do anything with a mobile phone, there's a massive device farm. There's dozens of different providers of that kind of stuff. All of it is just there for the taking, basically. It's more of a contractual problem than a technical one. Cars aren't that. Every car manufacturer is going to have its own infrastructure, its own OS, multiple OSs, multiple complexities of that device, potentially different builds in different regions. It gets more and more complex. So you can only really solve that, and again, revolutionary in the industry is focusing on virtualization of those devices. So I don't know if people might have seen the concept software-defined vehicle floating around. Quite a new concept. It's essentially around virtualize as much as possible of the vehicle architecture to allow you to move at pace. That's really the fundamental process behind it. This kind of thing here is just a bit of a setup of how we do some of our testing at scale. So as well as something that's not shown here, which is integrations with our testing hardware, managed as if it's just a part of the cloud. That was quite a big problem to solve, given how bespoke it is. This is also about managing the scale of that data and making it real for our testing. So there's kind of a virtualization layer here in the middle that takes in these tasks. So each one of these tasks is potentially going to be representing part of a vehicle, virtualized as part of that build process and submitted into this estate. And then it's scaled way beyond what JMeter was designed to do by this process. So essentially the data itself is fuzzed real data to make it realistic. And then it's massively scaled out, and each one of these tasks kind of can represent a vehicle. So based on real data, we can create a virtual set of vehicles driving in the cloud that we use to test this stuff at scale. So you're talking, up to 2 million virtual vehicles, which is, ahead of where we need to be. Which is another key thing about scaling, we think, is it's all very well you've planned for it, but you need to prove it empirically. And this is what we do, basically. We get a step ahead of where we need to be using this process. So you can see that VCDP, that's the name of our core data platform for our future vehicles. Some big payloads down here. You can see at the moment we've got 1.8 million virtual vehicles testing. If JLR had 1.8 million new Land Rovers on the road, I'd be paid a lot more. So it'd be good if we get that far. Yeah, some results. Again, I won't go into too many details, but you can kind of see here people who are used to seeing these things. Some of the kind of the 2 peaks is a key thing here, and the smoothness and all this kind of detail we can get out of that testing payload, that testing process. I mentioned cost, dialing that cost up and down. This also helps us predict that as well. This is tied into our FinOps process, so we can scale that too. All that kind of stuff. And this is all run with a GitOps approach as well. So I mentioned templating at the heart of everything, parameterization. So we can run as small or as big as we need to be. So you need a small run in an automated pipeline quickly. You can run the same stuff in a small scale. If you want to run it en masse for a gigantic load test running over days, you can do that as well using exactly the same process, just parameterized differently. So yeah, some stuff there. And then security. So I mentioned this is the last thing. So don't roll your eyes at app security. It's a big thing in cars, as you can imagine. Getting compliance with the regulations that you need to in automotive, but also being able to work properly at scale, at pace, really required some transformative stuff in the industry, and we've led the field with this. There's a regulation called Reg 155 that anyone in automotive would roll their eyes at. It's basically a massive amount of security, extra stuff you need to do to sell cars in the EU. We're the only car company that got a 3-year certificate to do that, and we did it with this process that's completely hands-off, based on this monitoring here. So all the security tooling I alluded to before and the ops monitoring all come together in one place, so we can prove our response to this stuff. So the second DevSecOps basically really made real. So that's that one, and that's the next talk. So I'm going to start.